Hello and welcome back. So this video is for class 10 and we will continue with our chapter of electricity. Now in the previous class we spoke about the concept of resistivity, right? And I hope that the difference between resistivity and resistance that was properly understood. Today we are going to talk about a combination of resistors. Means normally whenever we are constructing any kind of circuit, one single resistor is never enough, right? We need to have different combinations of resistors. Sometimes you might need more resistance, sometimes less resistance, right? So to do that we have a combination of resistors. So today we are going to find a formulae to find out what will be the total resistance when resistors are connected in a combination. Okay, so let's begin. Okay, so now there can be two types of combinations. One is called as a series combination and the other is called as a parallel combination. Okay, this we are talking about resistors. Now what is a series combination? In a series combination, the resistors will be connected back to back. Means if we have one resistor here, that is let us say R1, the other resistor, if we want to connect in series, it will be joined to that resistor in the same line like this. Okay, so they are going to be connected back to back and that will be called as a series combination. The other one is called as a parallel combination. In parallel combination what we have, you will see kind of the resistors will be stacked one above the other. Means we will have a combination like this. If this is one resistor R1, this will be the other one. Let us say R2. Their ends are going to be connected to each other in this manner. Okay, when such kind of combination is there, that will be called as a parallel combination. Okay, now of course we are going to see each of these one by one. So first we will solve what will be the total resistance for a series combination. Okay, so now we are going to connect three resistors in series with each other. And how do we connect that? We take one resistor, let us call it R1. That will be connected to the other resistor, let us say R2, which will be connected to a third resistor, let us say R3, right? So when they are connected back to back like this, we will say this is a series connection, right? Now to these let us attach one ammeter and a power supply, and here we will have our key. Okay, this should be positive, this will be negative. So now this connection that you are seeing here, this is three resistors connected in series, right? And now we want to find out what will be their total resistance. We also call it as the effective resistance. Why effective resistance? See, it happens like that three resistors connected in series, they will actually act like one resistor which will have some total resistance, equivalent resistance, right? And then the current in that entire circuit will be controlled accordingly, right? Now let us say this power supply that we have connected over here, this is going to give a potential difference of V. So this point here, let us call it A, and this point here, let us call it B, right? We see that between the points A and B, three resistors are connected in series, and to the same points we have also connected our power supply, which is giving a potential difference of V. Fine, so I think till here it is understood. Now, when you are solving the derivation for resistors in series, you are going to remember two things. First thing you will remember is that because all resistors are connected in series, if there is a current I which is flowing through the circuit, in each of the resistors, the same amount of current will flow. Okay, so once again, because three resistors are connected in series, the current flowing from each resistor will be the same. In this case, let us call it I. So first thing you will remember is that current will be the same for all three resistors. But what will be different? The voltages for the resistors will be different. Means across R1 we will have some potential difference, let us call it V1. Across R2 we will have some potential difference, let us call it V2. And across R3 we will have some potential difference, we will call it V3. So these potential differences are going to be different. Okay, so in a series combination, current is going to be the same, but potential across each resistor is going to be different, right? And what will happen is that if V is our total potential difference, we get V is equal to V1 plus V2 plus V3. What is V1? Potential across R1. V2 across R2, so on and so forth. So you get V is equal to V1 plus V2 plus V3. This we will call as our equation number 1. Right? So I think till here it is understood. Now we are going to use the Ohm's law. Right? Now what Ohm's law will say? That potential difference is equal to current into resistance. So how much will be V1? By using Ohm's law we can write V1 will be equal to I R1. Correct? I, we are not writing I1 because current is the same. So we need not write I1. So according to Ohm's law, V1 will be I into R1. Of course, we are assuming the key is closed while these operations are going on. Similarly, by using Ohm's law, we can say for R2, V2 will be equal to I R2. Once again, you will see I, we have not given any subscript, and V3 will be equal to I R3. These three equations we have got by using the Ohm's law. Right? I think that is understood. Then we can use all these three equations in our first equation. Correct? And also we can say the total potential difference V will be equal to I into R. Now what is this R? This R is the total resistance or the effective resistance. Let us call it as RS. I am writing it as RS because it is for the series combination. It is easy to understand. Okay, so total potential difference V will be equal to total current into total resistance, and total resistance we have considered it as RS. Now using this 1, 2, 3, 4 equations, in equation number 1 we will get this equation as, in place of V you will write IRS is equal to, in place of V1 you will write IR1 plus IR2 plus IR3. Correct? Now what do we see over here? In the right hand side, you can take I common out of the bracket. Right? If you take I common, you will get this as I in bracket you will get R1 plus R2 plus R3 is equal to IRS. Right? And then I can get cancelled on both the sides. So you will be left with RS is equal to R1 plus R2 plus R3. This is giving us the effective resistance for this series combination. So whenever we are having resistors connected in series, the total resistance will be the sum of their individual resistors. Correct? So in place of let us say 3 resistors, we had n number of resistors. This equation would become RS is equal to R1 plus R2 plus R3 plus, and it will go on till Rn. Rn being whatever is the last resistor that we have connected. Correct? So I hope this derivation is understood. And of course what you can see from here, let us say R1 is of 10 ohms, R2 is of let us say 5 ohms, and R3 is of let us say 3 ohms. Correct? What will be the total resistance? Total resistance will be 10 plus 5 plus 3, which will be 18 ohms. So for this combination, the total resistance RS you will get as 18 ohms. So what has happened to the total resistance? Total resistance has increased. So in a circuit, whenever we want to increase the effective resistance, correct? And why would you want to increase the resistance? Simply if you want to decrease the amount of electric current, right? So if you want to increase the resistance, connect the resistors in series, and the formula is very simple. If resistors are connected in series, the effective resistance will be sum of the individual resistors. So that was the derivation for resistors connected in series. Now we will do the same thing for resistors connected in parallel. Okay, so once again let us take, now this time we will take only 2 resistors, okay, to keep things simple for us. So here you have one resistor, let us say that is R1, which will be connected in parallel with another resistor, call it R2, and this will be once again, it will be connected. Here let us put an ammeter, and this will connect to a power supply, correct, which is going to give a potential difference of V. This point I will call it A, and this point I will call as B. Okay, so I hope the circuit diagram is clearly understood. So you see R1, R2, they are connected in parallel to each other, right? Why they are connected in parallel? We can see that one end of R1, the other end of R2, they are connected to a single point A, and the other end are connected to a single point B. That is how you can understand that they are connected in parallel. Now let us say I is the total current flowing in the circuit. This current I, when it comes to point A, you can see there are two branches that we can see here. So what will happen in a parallel connection, the current I is going to get separated, it is going to get split. So in R1, now you will get a current equal to I1, and in R2 you will get a current equal to I2. So for parallel combination, what you will remember, that the current in each resistor is different. In series, current in each resistor was the same, but in parallel combination, current in each resistor will be different. But what will be same? The potential difference V is going to be same, because you can see both the left hand side of resistors are connected to A and right hand side is connected to B. Thereby potential difference for R1, R2 will be the same, but current will be different. Okay, if this basic difference you understand between a series connection and parallel connection, you can do the derivation very easily. Right? So hopefully now this part is understood. Now we will go for our derivation. So now as we know, the total current I is getting split up into two parts, I1 and I2. Again, when that current comes here, that is after B, again that current becomes equal to I. Correct? So now we can write therefore the total current I is equal to I1 plus I2. Now this we call as our first equation. Correct? I being the total current which is equal to I1 plus I2. Fine? I think till here no problem. Then by using Ohm's law for R1 we can write V is equal to I1 R1. Correct? Again we are using Ohm's law, but now we are not writing V1 because voltages are the same. So for the first resistor you can write V is equal to I1 R1, or therefore you can write I1 is equal to V divided by R1. Correct? So I1 can be written as V upon R1. Similarly for the second resistor, what you will get? You will get I2 is equal to V upon R2. Correct? I hope you are following how we have got this. V is equal to I1 R1, thereby I1 is V upon R1, and same treatment you will do for R2, where you will get I2 is equal to V upon R2. And we can say for the total current, if I is the total current in the circuit, that will be equal to the total voltage divided by the total resistance. Let us call it RP now. Okay, RP being the total resistance of the parallel combination. Correct? I think these equations are understood. Then using these 1, 2, 3, 4, these 4 equations, we'll put again in our first equation. Right? If we put all these in our equation number 1, what do you get? In place of I, we will write it as V upon RP is equal to, in place of I1 you will write V upon R1 plus in place of I2 V upon R2. Right? Then what can you take common? You can take this V common, right? And then you will get therefore V upon RP is equal to, when this V comes out, it will be equal to V into 1 by R1 plus 1 by R2. And then you can see that once again we can cancel out the common part, that is V. Right? So you will get 1 by RP is equal to 1 by R1 plus 1 by R2. So when resistors are connected in parallel, the reciprocal of the total resistance is equal to sum of reciprocals of the individual resistors. If we are having n number of resistors, this equation will become 1 by Rp is equal to 1 by R1 plus 1 by R2 plus up to 1 upon Rn. Correct? So that is the formula for resistors connected in parallel. So once again let us write down the formula. For resistors connected in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. The formula might look like it is confusing, but it is a very simple formula. It is simply sum of the reciprocals. Okay. And how do we understand this? Let us say we are given two resistors. R1 is of 10 ohms and R2 is also of 10 ohms. Okay. These two resistors we are going to connect in parallel. What will be total resistance? Let us find out. 1 by Rp will be equal to 1 upon R1, which is 10, plus 1 upon R2, which is also 10. Right? Now can we solve this? Yes. we will solve this by taking LCM. We'll get this 10, 1 plus 1 will be 2, so we'll get 1 by Rp is equal to 2 by 10. But how much is Rp? Okay, 1 by Rp is 2 by 10. Rp will be equal to 10 upon 2, which is equal to 5 ohms. Getting the idea? So you had one resistor of 10 ohm and the other also of 10 ohms. But when they were connected in parallel, the total resistance became 5 ohm. So what you are noticing is that when resistors are connected in parallel, the total resistance will decrease. It will be smaller than the smallest resistor. Getting the idea? So whenever we want to decrease the resistance, we attach resistors in parallel. Okay. So make sure these formulae for resistors in series and resistors in parallel you have understood very properly, and write these derivations in your notebooks.